Okay.
Cool. We are officially recording. Thanks for being here, everybody that's joined us on the call. And thank you, especially Ellen, for wanting to host on this subject that you have a ton of wisdom on, which we'll get into in a second. But if you are somebody that cares about your health and wellness, and especially if you're a traveler and want to know more about antibiotics and vaccines, you're in the right place. You're about to get blasted with some knowledge. But before I pass the mic over, let me just cover the housekeeping stuff real quick if this is your first knowledge drop or you haven't joined before. But basically, there's a chat box. Feel free to chat with all the other people that are on the webinar. Just make sure it's set to all panelists and attendees. And there's also a question and answer box. So if, as we're going through the deck that Ellen prepared, if you have a question that comes to mind, just pop it in there so we don't forget, and we can circle back to it, hopefully, if we have a few minutes at the very end of the call today. But yeah, other than that, like I said, this is getting recorded. This will live on in the Knowledge Drop blog archive that we have going with all of our previous knowledge drops. You can always send that link around to friends, family, whoever has questions about when to take antibiotics or about which vaccines they should take when they're traveling, and or which vaccines they should get when they're traveling, or any other questions related to those two primary subjects. But it's not my information to share. It's Ellen's, so I'm going to pass it over. Take it away, and thanks again for doing this. It's awesome.
All right, let's get this screen share going.
Let's do it.
All right, so thank you everybody for coming. And this is a talk that was actually supposed to happen about a month ago, but as Slack made fun of me for at the time, I was too sick to do it. So don't worry, that's not the end of that. We're going to poke fun at me a little bit throughout this because of those wonderful illnesses. But with that, let's get going.
Such good time. Still saying anything.
What I'm going to talk about today is basically what some common misconceptions and mistakes are from the perspective of using antibiotics and vaccines, and also what a digital nomad or world traveler should know about those antibiotics. Importantly, I'm not going to be telling you what vaccinations you need or what antibiotics to carry with you. This is informational only, and I'm not a doctor. So, but why I am doing this knowledge drop, or what I like to call my nerdy credentials, I have a master's degree in microbiology and immunology from the University of Michigan. Go Blue. I have 10 years of biomedical research experience, and the most recent research that I did was on a bacteria called Streptococcus pneumoniae, which, as you could probably guess from its name, causes pneumonia, as well as ear infections. But particularly what I studied in that bacteria were the genetic systems that actually control that bacteria being able to become antibiotic resistant. So I did lots of stuff with antibiotics, antibiotic resistance, all that jazz. So with that, let's get into it. So firstly, we're going to talk about vaccines and how they work. So to kind of lay the foundation for that, we're going to talk a little bit about infection and how your immune system responds. So when some sort of foreign invader, a bacteria, virus, whatever, enters your body, it multiplies, it attacks, and ultimately it causes an infection. And this is what makes you sick. So what happens in response to this is your immune system, which includes cells, proteins, the organs within your body, it protects you against the infection. It's basically like the army inside of your body. So when something attacks, it defends against that foreign invader. And this is what's called an immune response. Your immune system primarily does this by releasing what are called antibodies, which these are like, if the immune system's the army, the antibodies are like the soldiers. And they take a couple days to mobilize, but once they do, they weaken and subdue whatever invading foreign dude has come into your body. Once this has happened, your immune system has a method to remember the foreign invaders that it has previously experienced. I kind of like this little graphic to demonstrate that, where the little immune cell army guy is taking the mugshot of the foreign invader. It's basically they take a snapshot, so whatever it was previously exposed to, if that infection comes back, the immune system can respond even faster. So ultimately, this is where vaccines come in. Vaccines provide that memory component without you actually having to get sick. And the reason why this is so important is because there's some diseases that are so deadly that they're really, really dangerous for you to have to respond to naturally. Some of these things are the very common things we get vaccinated for when we're kids, things like measles, polio, or the thing that is often, the big example that people use with vaccines is smallpox. So smallpox was a huge problem in the 1900s. It had a 30% mortality rate, so meaning if 3 people were ill with smallpox, 1 of those people were going to die. It had a 1 in 3, kill rate, if you will. But it was actually eradicated in the 80s because they had this mass global vaccination campaign that actually completely wiped it out. So that's why vaccines are so important and why they're so important for these particularly deadly diseases. They're also important because they protect the community. And RY, we're all about our communities, right? So protecting the community is what is ultimately called a herd immunity. And how this works is when a bacteria or a virus enters a population, there has to be people within that population that bacteria can actually infect. So if everybody's vaccinated, the vaccinated people in the population actually protect those people that are unvaccinated. And I really liked this cartoon to demonstrate that. So this bacteria is trying to come in. He's infected this first cell here, but every cell around it is vaccinated. So that disease isn't able to spread throughout the community because the vaccinated people are protecting the rest of the community. On the contrary, though, in this next panel down here, this bacteria, he's going to town because he's able to infect that first person, and because there's so many unvaccinated people throughout the population, that disease is able to spread throughout the population. So vaccines are also really, really important for protecting our community. Now, I wanted to include this slide in here because I knew somebody would probably ask the question of, are vaccines safe? There's obviously a really big thing right now with, anti-vaxxers, and I'm not going to really get into that because, yes, ultimately, vaccines are incredibly safe. There's a lot of testing done on vaccines to make sure that they are ready to be used in humans and that they are safe to be used in humans. They do laboratory testing. Once everything passes, the laboratory testing inspections for safety, they'll then move into clinical trials. And they do clinical trials in different age groups, people with different levels of, the strength of their immune system. They do small clinical trials. They do gigantic clinical trials. So they're very, very diligent and rigorous in analyzing these vaccines in people before they put them in the population. And when they do these, they're determining the safety, the proper dosage that they should use, and if there's any sort of immune reaction to the vaccine. You want the immune response to only be to, the foreign invader, not the vaccine itself. Even once they've approved vaccines for use in the population, each batch of vaccines that's then made after that, those are also tested. They test them for potency, they test them for purity, they make sure they're clean and sterile and good to go. And then once again, there's another tier. Once they're even in the population, there's monitoring that's constantly going on. Every year when flu vaccines go out, they're constantly monitoring, is this vaccine safe? Are there any side effects? And if there are, that vaccine gets immediately taken off the shelf. So they're very, very diligent and very rigorous about testing the safety of vaccines. So how does this apply to a digital nomad or a world traveler? Well, ultimately, as we all know, preparing for our RY travels, there were lots of vaccines that for some places you had to get because they were a requirement for entry to certain countries. Some of these are things like, hepatitis A, maybe typhoid, yellow fever is a big one that comes up. I just noticed that does not say fever, it says fewer, but yellow fever. But I also believe that just because, some sort of travel website or even a travel doctor recommends that you should get this vaccine, doesn't mean you should necessarily blindly take their advice. There's some, questions that you could ask yourself to really hone in on whether or not you truly need that vaccine. So the 3 questions that we're going to go through one by one are, what vaccination should you get? The likelihood of catching the illness, and is the vaccine effective? So ultimately, for that first question, what vaccination should you get? This is where the requirement to entry piece comes in. So some vaccinations you just have to get for your travels, but there are also some that are just on the recommended list. So in terms of getting this information, I personally use the Center for Disease Control travel website, the CDC out of the US. There's probably, health agencies from other countries or, the World Health Agency that you could also use. But in particular, I like the CDC website. I think it's very easy to navigate and the information is very straightforward. Or if you don't trust yourself to get this information off a website, you could always consult with a travel doctor, somebody who specializes in travel medicine. In terms of the second question, the likelihood of catching the illness. So this is one of those, it depends kind of questions. So ultimately, whether you should let this affect whether you get a vaccine or not, it really depends upon the vaccine and the immunocompetency of the individual, as well as some other questions, which we'll get to in a second. Immunocompetency, when I say that, it refers to the strength of a person's immune system. And the reason why this is important to consider is because children, pregnant women, people with AIDS, people who are, preparing to get a transplant or have other illnesses that are suppressing their immune system, those people are at a higher risk of having complications from getting certain vaccines. So if you are one of those people, whether or not you get certain of these vaccines is going to be important. Other things to consider in the context of the likelihood of catching the illness is ultimately how serious is the infection. Something like yellow fever, and we're going to talk about yellow fever throughout this, that's a very, very dangerous disease. So ultimately, do you want to potentially risk contracting a disease that is very dangerous? That's a vaccine that you probably want to consider getting just because of the severity of that infection. Additionally, you could ask, what region will you be in, or what types of activity will you be engaging in? Rabies is a good example in that one. If you're going to Argentina, for example, but you're going to be in Buenos Aires the entire time, you probably don't need to get a rabies vaccine. But if you're going to Argentina to work as a veterinarian to help, control the dog population or something like that, you are more likely to encounter a rabid animal. So in that situation, you'd probably want to get a rabies vaccine. Additionally, the region is really important for some of these things. So I have a picture of Iguazu Falls on this slide, and the reason I do is because if you're going to this region, that's probably the only time you truly need a yellow fever vaccine when you're visiting Argentina. And the reason for this is because not only is that tropical climate really conducive for the spread of yellow fever because it's spread by mosquitoes, so tropical climate, lots of mosquitoes, and also this region is very, very close proximity to a region of Brazil that has a lot of yellow fever problems. So that's an example of how regionally maybe it would be a good idea for you to get a vaccine. And then lastly, are you likely to even get the disease? I have smallpox on here. And as I mentioned in the previous slide, smallpox is eradicated throughout the world. The majority of us, normal people don't need to get a smallpox vaccine. But, people like military personnel, they actually do, because smallpox is something that's on a bioterrorist watch list as a potential bioterrorism agent. So as normal people, we don't need to even consider that. But there are subgroups of people who do need to consider getting those vaccines. Question 3 is the vaccine effective? And to demonstrate what I mean by this, I'm going to use 2 primary examples. Firstly being yellow fever. So as I mentioned before, yellow fever is a very dangerous disease. It's transmitted through mosquitoes, has a really, really high mortality rate, and actually having this stat to the right here, 90% of unvaccinated persons die from yellow fever. So it's kind of nasty stuff. But the vaccine for yellow fever is actually really, really effective. It's got a 75 to 95% efficacy rating. So, if it's between potentially contracting yellow fever, which is dangerous, or using a really effective vaccine, pretty obvious. You probably just want to get the vaccine in that instance. On the contrary, though, another example is typhoid. So typhoid is something that's contracted through contaminated water or contaminated food. And ultimately, it's not that dangerous of a disease. It's very mild. You can treat it with antibiotics. And, its vaccine's not that good. So is getting that vaccine really necessary? Probably not. An important thing to consider when it comes to vaccine and the effectiveness of vaccines is that their effectiveness can vary by subgroup. So I've already mentioned that, different subgroups of people have at varying degrees of how strong their immune system is. So children have a very different immune status compared to adults. The elderly have a lower strength of immune system compared to adults. So you have to take these things into consideration when you're talking about how effective a vaccine is. All right, so that's really my spiel when it comes to vaccines. But now I really want to move into antibiotics, which is actually the crux of why I originally wanted to do this knowledge drop. Because I think there are a lot of mistakes that we make when it comes to antibiotic use. So firstly, what are antibiotics? They're essentially chemicals that we use that include a bunch of small molecules, but this is the important part. They only target specific parts of bacteria. Now, viruses, not fungi, I almost said funguses, fungi, parasites, they don't target those things. They are very, very specific to bacteria. And the reason why this is important to consider is that there are illnesses that are caused by bacteria that actually can be also, that have similar symptoms to illnesses that are caused by viruses or fungi or parasites. So it's important to consider that because you might think you have a bacterial infection when really it's caused by one of these other things, and taking an antibiotic in that instance is going to completely be ineffective to treat that illness. So this is something that's really, really important to consider when it comes to taking antibiotics. Importantly, though, it's also important to consider that not all antibiotics work for all bacteria. So not all antibiotics are created equal here. there are basically two big groups of antibiotics, or two different classes that they can be broken into. There's broad spectrum antibiotics and there's narrow spectrum antibiotics. So broad spectrum, as its name implies, they work on a wide range of infections, a wide range of bacteria, as opposed to narrow spectrum antibiotics, which are really only effective against a few types of bacteria. So two examples I have on here is azithromycin, which targets a protein that's broadly found in bacteria. It's found in the vast majority of bacteria. So this is an antibiotic that you could take that would kill off a vast majority of bacteria. On the contrary, though, aminoglycosides, they target a different protein that is very, very specifically only found in one of the two major groups of bacteria. It's only found in gram-negative bacteria. So if you have a UTI, urinary tract infection, acronyms. If you have a urinary tract infection, those are often caused by gram-negative bacteria. So you could take an aminoglycoside, but if you have strep, that's caused by a different type of bacteria. So this is not an antibiotic that would work. So what this means for you is that if you haven't been prescribed that antibiotic by your doctor, specific for whatever bacteria you have, you may think you're taking something that's effective against the bacteria that is infecting you when it's actually not. So that's something that's really important to consider. Additionally, I want to talk about antibiotic resistance, because this is huge, and this is one of the biggest reasons why antibiotic misuse is causing such a problem in global health. So antibiotics are great. They're great for helping us treat certain bacterial infections, but ultimately bacteria can develop resistance to these antibiotics. And basically when this happens, all the antibiotics that we previously used to treat a bacterial infection, they're no longer useful in treating that bacteria. And how bacteria do this is ultimately they can change their structure, they can acquire new genes or new tools that allow them to be protected against the antibiotics. There's one type of antibiotic resistance that's very common. It's called an efflux pump, and basically it's like a water pump on the outside of a bacterial cell. So the antibiotic will move into the bacteria, think it's, oh yeah, I'm going to kill my bacteria, and this little pump immediately pumps it back out before it can do anything to target the bacteria. Another big problem with antibiotic resistance is that we were discovering a bunch of different types of antibiotic and different classes of antibiotics all through the 1900s, particularly in the 50s and 60s, as you can see in this diagram, but we haven't actually discovered any new types of antibiotics since the late 80s. So we are really running out of different types of antibiotics that we can use and different ways we can treat certain of these infections. So some causes of antibiotic resistance. The overprescription of antibiotics is a big one. So that's the people who go into their doctor and have, say, a viral infection or a parasitic infection, but insist that their doctor prescribe them antibiotics. That's a big problem when it comes to causing antibiotic resistance. Additionally, patients not taking their antibiotics as they're prescribed. And we're going to touch on this a little bit more in a second, but you have to take your antibiotics at the correct dosage over the correct course for us to prevent antibiotic resistance. Additionally, unnecessary antibiotic use in agriculture. Obviously, we as people who don't work in agriculture can't do much about this, but this is a really big one. And if you are somebody who works in agriculture, I highly suggest reading up on this. Poor infection control at hospitals and clinics. So if you have a patient with antibiotic resistance and you aren't controlling that infection, it gets spread to other patients. And lastly, poor hygiene and sanitation practices can also lead to spread. So some of the problems that result from antibiotic resistance, as I mentioned in the last slide, we're not discovering new antibiotics fast enough, and it's causing a lot of problems in terms of giving us options to treat some of these diseases. So it's becoming a really, really big problem. Some complications of antibiotic use. So there are some very general complications, and if you've taken a lot of antibiotics, you've probably experienced some of these. So these include stomach cramps, diarrhea, nausea, and then sometimes people also experience allergic reactions. So penicillin allergies are very, very common, but there's also times where people will develop allergies to cephalosporins, which is another type of antibiotic, or tetracyclines. Some more serious complications that can arise from antibiotic overuse, and this is different. It's not just using antibiotics, but misusing antibiotics or overusing them, include renal damage or damage to your eyes, kidney damage, liver dysfunction, and the potential to contract healthcare associated infections. And I'm going to talk about one of those in particular that is very, very uniquely tied to antibiotic use. And it is a bacteria called Clostridium difficile. So C. difficile, or C. diff, for short. And basically what this is it's a bacteria that's normally found in our stomachs. It colonizes about 3% of people throughout the world without actually causing them any symptoms or any problems. And I know 3% doesn't sound like a lot, but when you think about it on, the world population scale, that's actually a lot of people. What the problem is with this bacteria is it lives in our stomach, and it lives there with a number of other normal bacteria. And these normal bacteria are usually protecting against pathogens or disease-causing organisms from causing problems within our stomach. But when we take antibiotics, particularly broad-spectrum antibiotics, it kills off all of those normal bacteria that are in our stomach. And that ultimately allows a bacteria like C. difficile to grow and thrive and cause a lot of problems. And these problems can range from just normal diarrhea to ultimately a really life-threatening condition that's caused by inflammation of the colon. So serious stuff and very, very tightly linked to antibiotic use. So how does this impact somebody who's traveling? So a lot of people bring their own antibiotics with them when they travel, to combat traveler's diarrhea or whatever other ailments they might deal with. And this causes a lot of problems because, and I've heard people say this, we tend to take antibiotics very haphazardly. So if we just have an upset stomach one day, I've heard somebody say, I had an upset stomach, so I just took an antibiotic. We use them for even mild ailments, things that might not ultimately be an issue, things that could be fixed simply by, changing our diet, taking an Imodium, hydrating. But if we do ultimately need antibiotics, that might not be the right antibiotic for whatever infection that we have. It might not be the right dose. It might not be the right course. And ultimately, it might not be an infection that's caused by a bacteria. And I know I've been hammering that one in, but that's really, really important. So these are some of the problems that are associated with that haphazard use of antibiotics. Additionally, there's actually been a new study that came out, which I unfortunately don't have time to go into today, that showed that people who take along their own antibiotics are more likely to return with antibiotic-resistant bacteria, which can cause problems for their own health and potentially problems for their community. So to wrap things up, I have a little case study of myself, because as I mentioned at the beginning of this, I was supposed to give this talk about a month ago when I was in Mexico, and I got really, really sick, and Slack had a lot of fun with that when I got really sick. The girl who's supposed to give the antibiotic talk is too sick to do it. Ultimately, I had a lot of nausea, and it was very unpleasant for a concentrated period of time. But ultimately what I did is I waited 24 hours to see if the symptoms went away. And this is actually a good tell. Viral infections tend to resolve themselves relatively quickly, or at least improve relatively quickly. So I waited about 24 hours to see if my symptoms went away, and ultimately they did. In this instance, all I really needed for my illness to improve was I needed to rest, need to hydrate, drink lots of electrolytes, and just eat a very plain diet. And, it took a few days for me to feel, 100% again, but my symptoms went away relatively quickly. Now, we're going to compare this to Portugal. So we just arrived in Prague. We were in Lisbon. And about a week ago, I got really, really, really sick. Again, I know apparently I'm just a walking disaster right now. But this time, I had a really sore throat. I had a lot of difficulty swallowing. And in this instance, I considered a lot of my past experiences. I had a lot of problems with strep throat, for example, when I was growing up, particularly when I was in high school. So I considered those experiences. I also did my own little bits of research. WebMD can be useful to confirm some of your symptoms. So I checked my symptoms against those online resources. I waited once again to see if my symptoms resolved or got better. And they didn't. Ultimately, I called International SOS, thank God for them, to get a second opinion. And they told me, go to the doctor, we think you have strep. And that's exactly what I did. And ultimately, the doctor prescribed me antibiotics. Like, I am now giving my antibiotic talk, taking antibiotics. Those are my antibiotics right there. But I wanted to tell you this story to demonstrate a situation where you do need antibiotics and a situation where you don't, to kind of give you a perspective on how to go about making that decision for yourself. So to wrap things up, I really want to give you some do's and some don'ts of taking antibiotics. So never insist that your doctor prescribe you an antibiotic. They know a lot better than you do of what you're potentially experiencing, whether it's viral, whether it's bacterial. So don't insist that they prescribe you antibiotics because you might not need them. Again, never take antibiotics for a viral infection. Flu, common cold, many diarrheal diseases, bronchitis, those are all caused by viruses, not bacteria, and antibiotics don't work against those things. Also, this is my rule of thumb: never take antibiotics when they're prescribed for someone else. Just like other things, antibiotics have a shelf life. And again, the dosing of your antibiotics and the course of antibiotics that you're taking is really, really important to combat your illness properly. If you are prescribed antibiotics, it's really, really important that you finish them even if you feel better. There's a reason why your doctor gives you an 8 to 10 day antibiotic course. And the reason for this is your bacteria that are causing your infection are a community. And within that community, there are different members. And the bacteria that have a really low susceptibility to that antibiotic or aren't highly affected by that antibiotic, those guys are still going to be around on day 6, 7, 8, 9 of your antibiotic course. So if you don't finish it, you're not killing off those straggler bacteria. And ultimately, those are the ones that can cause antibiotic resistance and can potentially cause a recurrence of your infection if you don't finish your antibiotic course. Okay, lastly, don't double up on dose. Dosing is very important to prevent antibiotic resistance as well. So if you accidentally miss a dose of antibiotics, just get back on the schedule with the next pill. Some do's: take antibiotics as prescribed by a doctor. I feel like I've hammered this one down enough, but just listen to your doctor. Inform your physician if you have any allergies to antibiotics. Again, penicillin allergies are a thing. And if you're a woman who's on birth control, you should also talk to your doctor about that. Certain antibiotics, very few of them, can make birth control pills less effective, and they also make women more susceptible to yeast infection. So something to consider and to talk to your doctor about. Discuss with your doctor if there are foods or alcohol that can negatively impact your antibiotic, just so you're mentally prepared. There aren't a lot of these things, but it's important to know if it does apply to you. Again, take the full antibiotic course, even if you feel better. I put that in there twice because that's probably the biggest mistake people make with antibiotics. And then lastly, avoid hospitals if you can. We talked about one example of a hospital-acquired infection. There are more, but you're more susceptible to those types of infections when you're on antibiotics. So really important to consider that. So that is all I have. How do I exit?
Woo-hoo.
Okay, there we go.
Yeah, you can jump out of screen share.
Okay.
Thanks, Ellen. That was amazing.
You are welcome.
You're so knowledgeable on this subject, and I feel like I told you, I feel like I've always had like a sort of decent understanding of this stuff, but like I realized from watching you give this talk, like I knew like a quarter of what I should probably know in terms of antibiotics and viruses. So thanks for being, a nurse of sorts to the whole nation and sharing your wisdom with everybody. And
no problem.
If there's anybody out there in Knowledge Drop Land who's a question, feel free to use the question and answer box. And we're almost at time, but I had one thought that I wanted to just like see, or a question sort of, if you could answer it, around the thing you were mentioning with like certain antibiotics only like attack certain types of bacteria. What's up then with like Z-Paks and just sort of some of the generic like antibiotics? Because I've seen a lot of travelers who are just like, I just travel with a Z-Pak, and when I don't feel great, I take them. And you kind of address why that's not necessarily the smartest thing.
Mm-hmm.
But I never really realized how like certain antibiotics might not, like if you have strep throat versus like a sinus infection versus something else that antibiotics might help with, you need like a specific type or?
It really, really depends. This was a massively oversimplified version of antibiotics. There are seriously like 15 different classes of antibiotics, and they're all specialized for certain types of bacteria. My understanding of Z-Paks and the reason why they oftentimes will help people is because they're broad spectrum and because, they just have that larger amount of coverage in terms of the different types of bacteria they can infect. But that whole why certain things affect certain types of bacteria in certain parts of your body, much more complicated of a question, and really starts to get into the nitty-gritty of the different types of antibiotic and the mechanism by which they get into your body and ultimately affect the bacteria. So that's kind of a loaded question, but Z-Paks work mostly because they're broad spectrum.
Okay, so they're good for like the majority of cases that could arise.
Yeah, the majority of cases, but that's the thing to consider with something that's broad spectrum is, especially if you're somebody who already has intestinal issues or GI issues, is broad spectrum wipes out your bacteria that live in your gut. So if you're already susceptible to that, you should probably limit the amount of, broad spectrum antibiotics you're taking, or at least the frequency at which you're taking broad spectrum antibiotics, because it's going to be harder for you to recover. And then, obviously the yeast infection thing for women is also a thing.
Last one real quick, because I got to get out of here too. But just in general, like I know it obviously depends on how like often somebody falls ill, but like when would you say somebody should start being like, oh, this might be too much in terms of like how many times per year? Like if you end up taking antibiotics, like 3, 4, 5, 6, like at what point would you be like, oh, I need to like, fix this or not take so many antibiotics somehow?
Are you asking more from like a traveler perspective or just kind
Yeah,
of general?
or just general health. Like if you know if you end up like, oh, this is like my 4th time this year taking antibiotics. Like at what point would you be like, this is too many times per year?
I mean, they're overarching list, unless you've seen some very specific side effects from taking antibiotics. I wouldn't say there's like maybe a cutoff of at what point it becomes dangerous. I don't think it ever becomes dangerous, but it also depends upon the types of side effects that you have. But in terms of, if you have to take antibiotics 3, 4, 5, God forbid, 6 times a year, I think the big question at that point ultimately becomes maybe you should start considering some lifestyle factor changes. Like that suggests to me that your immune system is just compromised, maybe because you're not getting enough sleep, maybe because your diet's not great. So there's maybe some lifestyle factors that you need to start considering to strengthen your immune system so that you don't have to take antibiotics every 2 years.
That's when you need to get into the natural remedies Slack channel.
Yeah.
Do some oil pulling and some whatever.
Yes, exactly. Or do some Kravisting.
All right, amazing. Thanks so much, Ellen, for giving this, and then thanks to those who joined, and hopefully to those who watch this video in the future and learn all about vaccines and antibiotics. Yeah, we'll be back in 2 weeks, or actually, I think 4 weeks this time for the next knowledge drop. And thanks again, y'all. Peace.